So let's start. Today we are going to talk about inclined planes. So one may ask, what is an inclined plane? So an inclined plane is when a support, that's any material such as wood, metal, is placed on an horizontal as well as a vertical surface. So let's say, for example, a leather placed on a wall has a horizontal component, which is the ground, and a vertical component, which is the wall. So look at this diagram to see how it looks like. So this is the diagram. As you can see a load moving on a surface. That surface can be a metal or a wood, moving upwards, and the length of the wood will be the distance that the effort must travel, right? So that's what we label it as L, and the vertical component, that's the height, is labeled H. Let's move on. So the L is equal to the length of the inclined plane. That's what I'm writing. And H is the height of the inclined plane. Also, there's an angle. We always put the support at an angle. So the angle there is angle of inclination. Note this. First of all, you have to know what is mechanical advantage and as well velocity ratio. So this is what you have to know in order for you to understand inclined plane very well. So now let's look at velocity ratio. From the definition, velocity ratio is the ratio of the effort distance to the load distance. So it's actually the ratio of the effort distance to the load distance. Let's move on. So it is represented by V dot R, which is equal to effort distance over load distance. You remember from the earlier diagram that we represent effort distance, that's the length of the surface, L, over the height, the vertical component height, H. So that's the load distance, H. So there is no unit for velocity ratio. You have to know this because they cancel out. The meters cancel out. The distance meters cancel out. So mechanical advantage is the ratio of the load force to the effort force. So it is represented by MA, which is equal to load over effort. Now, for the efficiency of a machine to be 100%, mechanical advantage should be equal to velocity ratio, which automatically will be equal to 1. But from the earlier diagram, you can express velocity ratio in terms of the angle. So by trigonometry, you know the sine ratio, so cut what? Sine theta is opposite, that's opposite over hypotenuse, and our opposite was the height, the vertical height, which is H, and our hypotenuse is the length of the surface, which is L. But we said that velocity ratio is equal to length over height. So inverse of the velocity ratio will be equal to height over length. So you just reciprocate the L on H to get H on L. That's the inverse of the velocity ratio. So from there you can say that velocity ratio is equal to sine theta, which is equal to H over L. So now these are the formulas for finding efficiency of a machine. So first of all, the efficiency of a machine is equal to the mechanical advantage over velocity ratio times 100. Also, efficiency is equal to work output over work input times 100. Clear? So let's solve some questions in order for you to understand inclined plane. So let's start. So a load of 50 newtons was raised to a vertical height of 4 meters, and the length of the plane was 5 meters, and the efficiency of the inclined plane was 60%. Find the velocity ratio and the effort. So we are told to find the velocity ratio and the effort. Let's move on to the solution. So the load, which is capital L, is equal to 50 newtons. From the question, always have to write your data. Vertical height, which is h, which is equal to 4 meters, and the length L, small l, which is 5 meters. Efficiency of a machine, which was given to be 60%, right? So but we all know that efficiency of a machine is mechanical advantage over velocity times 100, right? So we also know that velocity ratio is equal to the effort distance, which is L over h. So 5 on 4, we are getting 1.25. That's our velocity ratio. The velocity ratio, we were already given the values in the question, so you can just plug into the formula and find for the velocity ratio. Let's move on to finding the mechanical advantage. So we already said earlier, we are putting the values into it. So 60 is now equal to 100 times mechanical advantage over. So we send the 1.2 to the other side, multiplying 60 and 100 mechanical advantage. So now 60 times 1.2, which is giving us 75, and 100 mechanical advantage. So dividing by 100, we are getting 70 over 100. So we shift the point 2 times, getting 0.75. Note that I'm not putting unit there because mechanical advantage has no unit. They cancel out, the meters cancel out. Also, we know that mechanical advantage is load over effort. So let's send the effort to the other side of the equation, multiplying the mechanical advantage. So now we are dividing mechanical advantage over the load, getting the formula for finding effort. Effort is the load over the mechanical advantage, which is 50 over 0.75. And you had an answer to be 66.767 newtons. So therefore our mechanical advantage is 0.75 and our effort is 66.67 newtons. Thank you for watching. Bye.